Today, we are going to see the synthetic approach of finding the remainder of a given polynomial when it's divided by a given function. Now, the synthetic method is having one restriction, that it's used to find the remainder if and only if when the divisor is linear. So if the divisor is not linear, so we cannot use this approach. Now, we know that we can find the remainder using maybe other two methods. One is long division. We covered long division, and if you want to see more about long division, you visit the playlist. You'll find there more about long division. And you can also use what we call the remainder theorem. Also, the remainder theorem is there. Please go to the playlist and then look for long division and also the remainder theorem in polynomials. Now, the long division approach takes you a bit back. If you recall there, this is how you long divide, and we've seen that if this is the polynomial and this is the divisor, we are getting our remainder as 25 there. Then if you go to the main remainder theorem approach, if this is the divisor, x minus 2, we equate to 0 to get a root as 2. So then we get this root and we substitute in the polynomial given. So my polynomial is this, then I substitute a 2 in this function. When I substitute a 2 and I evaluate this, I get 25. You see that these two are giving us the same answer. So the remainder is 25. Now you want to see, is also the synthetic method going to give us the same answer? Now for synthetic method, we said we only use it if the divisor is linear. Linear is that now here our divisor is linear. Linear we mean the highest power of the dividing function should be 1. So it's always in this form ax plus b, where a and b are real numbers. So now from there, you saw this one is linear, so it qualifies. If it's quadratic, then I can't use this approach. Now, because it's linear, what we do, we write the powers. You see this is a polynomial to power 4. So what I do, I write it in descending order. So I put here my where x to power 0 is just the constant. Now, the next step is pick out the coefficients basing on the powers. So now I pick the coefficient of x power 4, which is now you see that here we don't have x to power 1. So meaning here from x power 2 is 6, but here the next would have been x power 1, but it's not there. So because it's not there, I put a 0 there. Now this is the constant, or the x to power 0, negative 7. You take them with their signs. Now from there, what we do, now we get the root by equating this to 0. When I equate this to 0, I get a 2. So now I get x minus 2 equals to 0. So I get my x as 2. Now I draw a line there. Then you leave one line, then you draw a line there like that. So what you do now, you bring now the coefficient of the highest power here like this. Then you say now 2 times 3, you get a 6. Then write it to the power to the next in the ascending order. So the product, you write it under this. So now you say 2 times 3, 6, write it under this. Now after you add, so this plus this, you'll be having a 1. Now 2 times 1, you get 2. Write it here. Then after you add 6 plus 2, that's 8. Then 2 times 8, I get 16. Write it there. Then 0 plus 16, you get 16. Then 2 times 16, 32. Then you add, you get 25. Now, what you get here, there is going to always be our remainder. So this figure there is acting as our remainder. So then it's therefore come and say, therefore, our remainder. So that's how the synthetic method works. Now, let me now maybe try another example. Now, this example I'm going to try is when we have it in that form. Still, it's that this one is now a polynomial to x power 3. So I start by writing them in in the descending order. Okay, so now the coefficient of x power 3 is 4. Then I come to then 10. Then the next thing is skip a line here, then draw a line there. Then you get the root by equating this to 0. So now what I do, when I equate that to 0, I have now 2x. Then my x as negative a half. So now here I put negative a half. So when I put here negative a half now, we say now you bring this here. You bring the coefficient of the x power, you start with that one there. Then this times this, so negative a half times 4, you get negative 2. Right there, right there. So this will be negative 2, like that. Then you add. When I add this plus this, I get negative 8. Then negative a half times negative 8, you get a positive 4. Then this plus this, I get 8. Then negative a half times 8, I get negative 4. This plus this, we get a 6. And then this one becomes the remainder. Therefore, our remainder is going to be a 6. So that's how the remainder, the synthetic method works. You can either try this using the other two methods, either using the long division method or the remainder theorem. It's going to give you the same answer. So members, that's how we use the synthetic method, but you should not forget that it works if you have a linear divisor. That's it, members. Don't forget to subscribe to the channel. You subscribe, and if you want more topics, you go to the playlists. That's it. I wish you well.